In the previous video I talked about case 2, and this video I will talk about case 3 of portfolio theory. Okay, so just to remind you, this is where the losses are I and ID, and n is a fixed number. Now, I and ID means that independent but not identically distributed. So let's consider the first variable, which is the CDF of the total portfolio loss. Which is, by definition, is this. And this you can write as, using the fact that the variables are independent of each other, you can write them as follows. Sorry, this should be little xi less than equal to s. Right? So that's using, so this step here uses independence. Okay. And in the next line I'm going to just rewrite what I have written. So I'll just rewrite this as follows. Right, so this is the CDF. Now the PDF is simply the derivative. Okay. Right, so that's the first variable. The second, okay, before I go to the second variable, let me just do an example. So this would be example number 6. So this is example 6. Suppose you have 2 investments, so n is equal to 2. Then the CDF of the total portfolio loss is the following. Is equal to this, and this you can write as the integral over this region of the product of the density functions. That's because the 2 variables are independent of each other. Alright, so let me write that again. This follows because of independence. Okay, independence of the two random variables. Right. Now in the next line I'm going to write this region as two integrals. The first from minus to plus infinity for x1, the second from minus infinity to s minus x1 for x2. Alright, as we saw earlier, this integral here, right, is simply equal to the CDF of x2 at s minus x1, right, by definition. So therefore this is equal to okay. So this is the formula for the CDF of S when the number of investments is 2. Now the PDF is the derivative of this. Okay, so you should differentiate this with respect to S. This is what you will get. You will get okay, right. So just one example on the total portfolio loss. Right, next I'm going to move to the second variable of interest, which is the minimum portfolio loss. Yeah, here we are. So this is B. Is the CDF of U is as follows. Right, this you can write like this. And this you can write as 1 minus the probability that capital U is greater than little u. You see in a minute why I'm doing this. And this you can write as the minimum x1 to xn is greater than u. Now if the minimum is strictly greater than u, then every single variable has to be greater than u. So x1 is greater than u till xn is greater than u. Right? And in the next line I'm going to use independence. Right, so this follows because of independence. Right, and in the next line I'm going to write this variable, this probability, as 1 minus the probability that x1 is less than or equal to u, and this one as 1 minus the probability that xn is less than or equal to u. And we know that this is 1 minus the CDF at x1, and this is 1 minus the CDF of xn at u. So this is the CDF of x1 at u, this is the CDF of xn at u. And this you can write as 1 minus the product I from 1 to n Alright, so this is the formula for the CDF of U. Now the PDF, of U is, you need to differentiate this with respect to U, and this is where your product rule comes in. So you should differentiate this with respect to U, you will get the following. So I'm going to use the product rule for differentiation. When j not equal to I. So if you wonder how I got this, I have used the product rule. The product rule for differentiation. Alright, so that's variable B. Next, I'm going to talk about variable C, which is the maximum portfolio loss. So you write this as this. This is CDF of V. By definition is the probability capital V is less than or equal to a fixed number. This is the probability that the max of x1 to xn is less than or equal to V. If the max is less than or equal to a fixed number, then each element has to be less than or equal. So is the probability that x1 is less than or equal to V up to xn is less than or equal to V. Now using independence, you can write this as this. So I have used independence here. Independence of the n random variables. Okay. Now this guy here is the CDF of x1 at V, and this guy here is the CDF of xn at V. And this you can write as the product I from 1 to n So this is the CDF of the maximum portfolio loss for case 3. Now the PDF the PDF of v is simply the derivative of this. So once again, I'm going to use the product rule for differentiation, so it will become as follows. Okay, so this is the, I have used one more time the product rule. The product rule for differentiation. Okay. Before I do some more examples, let me remind you about the product rules. I have used this in the previous slides. The product rules for differentiation. You must have learned this in your first year. But in case you forgot, let me remind you of them. Okay, so the first one is, suppose you have two functions, say g1 of x and g2 of x. Then the product rule for this is simply g1x times g2 prime x, prime denotes the derivative, plus g1 prime x times g2x. Okay, so this is the rule for differentiating the product of two functions. Now suppose you have a product of three functions. So say g1x times g2 of x times g3 of x. And in this case, the rule for differentiation is as follows: g1x g2x times g3 prime x, right, plus g1x g2 prime x plus g3x, and plus okay. So this is the product rule for differentiating a product of three functions. Now in general, if you have a product of, say, n functions, then the rule is as follows. Right, so this is the product rule for differentiating a product of n functions. So, and this is the rule I have used in the previous slides. Okay, so this is a reminder on the calculus. Now let me move on to do some more examples for case 3. So this is example Number 7, suppose you have two investments, right? Then the CDF of U, remember U is the minimum portfolio loss. Using the formula I gave you earlier, this will be equal to 1 minus okay, and if you simplify this, you will get the following. All right. Okay. Now the PDF of U is simply the derivative of this. So you differentiate with respect to U. Now for the last term, I'm going to use the product rule. So you will get the following. Right, so that's example 7. Next example. Example 8. Suppose once again that the number of investments is 2. Then the CDF of V, remember V is the maximum portfolio loss. Using the formula that I gave you earlier, is this, right? And the PDF of V, using the product rule, you will get this. Right, so that's example 8. The next example is the following. Example 9. Now suppose that the losses are distributed according to a normal variable with mean mu and variance sigma I squared, and mean is mu I. Independent random variables. Now the question is to find the distributions of S as the total portfolio loss, U is the minimum portfolio loss, and V the maximum portfolio loss. So let's start with the first one. Now, S being the sum of independent normal random variables, you may know from stuff you did in first and second years that the sum of independent normal is also normal. And in this case, it's normal with the following parameter. So the mean parameter will be the sum of the mu i's, and the variance parameter will be the sum of the sigma I squared. Right? So this total portfolio loss has a normal distribution. Hence the CDF of S is simply the CDF of this random variable, which is phi little s minus the mean parameter, which is the sum of mu I, and divided by the square root of the variance parameter, which is okay. So this is the CDF of S, where, as I said before, denotes the CDF, phi denotes the CDF of the standard normal variable. The PDF of S is simply the PDF of this normal variable, which is the following. Right, so right, so this is the density function of S, where the little phi denotes the PDF of N01. Okay, so we're done with the first variable. Now the second variable is the U, which is the minimum portfolio loss. So the CDF of U, using the formula that I gave you earlier, can be written as this. All right. Now this can be simplified a little using the fact, I'm sure you know the following fact, that if you have 1 minus phi of z, that can be written as phi at minus z. This is a result you should have learned in the year 1 or year 2. But if you don't remember, it's okay. All right, just try to remember this in the future. So you can, using this fact, you can write the above as okay. All right, and the PDF can be obtained by differentiating this using the product rule I mentioned earlier. Now variable C, which is the maximum portfolio loss, and for this the CDF of V is given by the following. Right, so this is the CDF of B. Right, so this completes example 9, and this also completes case 3 of portfolio theory. And in the next video, I shall talk about case 4 of portfolio theory.